Okay, today we're in section 5.3, identifying proportional relationships. In order for two ratios to be proportional, so we know in sections 5.1 and 5.2, we've been looking at comparisons between two quantities. We call them either ratios or rates. Okay, so now what we're doing is we're actually taking two ratios or two rates and we're setting them equal to each other in what we know as a proportion, okay? So a proportion is two ratios or rates that are set equal to each other, all right? So we see an example here, 1/2 equals 3/6. We know that it's truly a proportion if we can do a method called cross products where we multiply the numbers diagonal from each other and if they would equal out, okay? So 1 times 6 is 6. 3 times 2 is 6. All right, so that's how we can verify that this is, in fact, a proportion. All right, and then cross products is the method we use to solve. All right, so we see the cross product method displayed here in the 3 times 10 here, 3 times 10, and then the 4 times x. Right here. And what we'll learn tomorrow, actually we're going to do one today, but what we will learn mainly in 5.4 is how to actually solve these. Okay, all right, so let's look at our first example. Okay, it says, tell whether the ratios form a proportion. I don't know what that is. Tell whether the ratios form a proportion. Okay, yeah. All right, so let's first set up my ratios in fractions, okay? We're going to set up my ratios as fractions. 6 to 4 and 8 to 12. 6 to 4 and 8 to 12. So I'm going to say 6 over 4 equals 8 over 12. 6 over 4 equals 8 over 12. And in order to determine if it is in fact a proportion, I'm going to do my cross products. I'm going to multiply my cross products and see if they equal. What is 8 times 4? 32. And what is 6 times 12? 72. Do those two numbers equal each other? No. Okay, 32 does not equal 72. All right, 32 does not equal 72. All right, and it's really that easy. And I just say no. Now, notice also I put the line through the equal sign. Okay, that's just showing it does not equal. We're going to do a bunch of these. Okay. Yeah, it's a good bit of it. All right, so on B, I want you to set up your proportion. 10 to 40 equals 2.5 over 10. And we're going to practice our cross products. Remember, you are allowed to use your calculators. I would prefer it to be more of like a backup method versus the main. And do not do 10 times 10 in your calculator, okay? So we're not going to be reliant on these calculators. So 10 times 10 is 100. And what is 40 times 2.5? 100. Okay, 100. Do you guys want me to let you in on a little secret how I did this? No. Okay, mental math? Money. Mental math? No, not money. Okay. So basically, I'm doing 2.5 times of 40, right? So what's 2 times 40? 80. And then what's half of 40? 20. So 80 plus 20 is 100. Okay. So if it's ever 2.5 or 4.5, the easy thing to do is to multiply the whole number times that number, and then take that number and half it, and then you add the two together. Okay. So I just explained it. We're actually going to have another one in a minute. We'll see who can do it. All right, mental math. Now on C, what do you notice that's a little different about C? Fraction on top of a fraction. I'm still going to write it a fraction on top of a fraction, okay, equals the 8 over 4, okay? Now I'm going to multiply a fraction times a whole number. You absolutely can just pull it out and say 1/2 times 4 over 1, okay? You could do that. All right, and then you would be able to clearly see the answer. That would be my suggestion if you're confused. However, think about half. Half is a pretty easy one to do mental math. What is half of anything? You're just dividing it by 2, right? So half of 4, what would it be? 2, okay? So I'm going to let you in on another, you could call it a math hack, okay? Maybe I'll start calling them that, my math hacks, okay? Listen, guys, if 1 is in your numerator for a fraction and you're multiplying it by a whole number, this only works if 1 is in the numerator, okay? What you're actually doing is you're taking the denominator and you're dividing the whole number by the denominator, okay? All right, very good. So in this case, it was 4 divided by 2, which I actually saw it over there, which is 2. And now 8 divided by 4 is also going to be 2. And that makes sense, right? That 1/4 of 8 is 2. So basically, if I chopped it into 4 parts, it's 2, 2, 2, 2, which equals 8. All right, so, and it only works when 1 is in the numerator. But if 1 is in the numerator, I can take the denominator value and divide the whole number by that number. All right, that really helps you when you have to do all this multiplication and division with fractions. It could really help you. Again, if that confuses you, just pull them out, write them out, and solve them. Okay, all right, we're going to do 2 more. All right, so all we're doing is putting these ratios into proportions and testing whether or not they form a proportion. Go ahead and do these 2 together in your groups and check your answers with your buddies. All right, so on the next one, 6 over 9 equals 12 over 18. 9 times 12, 6 times 18. Okay, I need you to write yes. Did you write the word yes? Yes. Okay, and then you'll box it in. Oh, that was a squiggly box. That one's not much better. Okay, so that whole thing is your answer. You need your totals and the word yes. On the next one, 2 over 3, 4 over 5. 12 does not equal 10. Did you put the line through the equal sign? Yes. Did you write no? Yes. Okay. All right, then we're good. All right, so now we're on to example 2, telling whether or not values are proportional. So this is going to be a really strong connection into 5.1 and 5.2 because I'm looking now, okay, remember how we found the value of the ratio? That's essentially what we're doing here, okay? But we're basically taking our x and our y value and we are reducing them or putting them into a fraction, okay? So on the first one, 1/2 divided by 3. 1/2 divided by 3, that's 3 over 1, okay? Which would be 1/2 times 1/3, right? Because I have to flip that second fraction. What I'm trying to do here is I'm trying to find the value for the ratio. So 1/2 times 1/3 gives me 1/6. As long as every other value of the ratio is 1/6, okay, when I divide it, then I know that these values are proportional. Well, look at the next one. 1 divided by 6. Okay, so that one's pretty easy. All right. Now 3 over 2 divided by 9. That one's going to take a little bit of work. All right, go ahead and do that one. 3 over 2 divided by 9. Again, I'm looking for it to be 1/6, but don't force it. Don't like decide in your mind, this needs to be 1/6 so they can be proportional, and then you mess up something. There might be one that's off. That's what I'm trying to test for. I flip it. And I get 3 over 18. Oh man, it's not 1/6.
Wait, what? You reduce
Yes, I can reduce it. So don't forget to reduce it. All right, are you thinking, oh my goodness, she does not see this? Okay, so then 2 over 12, yes, also reduces to 1/6. So because they're all 1/6, this is not my answer. I must come over here and say yes. Okay, so there's lots of kind of work here proving all these values are actually the same. Okay, all right, let's look at our next table. Okay, so on the next table, that's exactly what we're doing. We're going to try to find the value of the ratio, make sure it's completely reduced. Otherwise, you might think it's not the same, but it actually is. All right, so go ahead and work through these. Start working through them. So on the first one, 2 over 4, did you get 1/2?
Yes.
Okay, so that's my target for the rest of them. Now on the next one, I had 4 over 2. When I reduced that, what did I get? 2 over 1. So right there, I see it's different. Actually, I don't have to keep going. If I did, look, 6 over 1, okay, obviously I can see these values are not proportional. My answer is no. My answer is no. My proof is in my work, and my answer is no. Okay? Please don't forget to say no. All right? I hate for you to do all that work and then forget that one part. All right, so here we go. Definitely the most difficult part of the lesson right here. Okay, so let's try to lock in and see what it's asking for. Okay, so first of all, number 3, it says you swim 20 laps in 16 minutes. Of the total laps swam, you completed your first 4 laps in 2.4 minutes. Are the rates proportional? So the first thing I'm going to do is I'm going to set up now my own proportion. Here is the most important rule for setting up your own proportion. You must be comparing the same value on both sides of the ratio. What do I mean by that? If I say for my first one, 20 laps over 16 minutes, the other side must be laps over minutes. Okay, so on both sides of the proportion, it's laps over minutes. So guess what? I could flip that and I could say minutes over laps as long as it's the same thing on both sides. So if I did 20 over 16 on the first side, what would I do on the other side? 4 over 2.4. So my first question is, are these rates proportional? We're going to talk in a minute about what it means. The first thing I want you to do, though, is just test it. Test it using your cross products. Are these rates proportional? Go ahead and do that, please. Okay, what's 16 times 4?
64.
64. Okay, and what's 20 times 2.4?
48.
48. All right, are these rates proportional? No. Okay, I want you to think now about the scenario. Okay, so this is a scenario. When we have scenarios, we want to think a little deeper on this. Why do you think, okay, so go back to what we're looking at here about swimming laps and your time. Why do you think these two rates are not proportional to each other, Colin?
Because if you're swimming 20 laps, you're not going to be able to keep your starting speed for that long.
Yeah, right? Samuel, you want to add to that?
You get tired after a while.
Yes, you get tired, right? Has anybody ever run like several miles? Okay. So usually that warm-up mile, like 1 mile, is kind of your warm-up. Then your second mile is like your fastest one, or it's getting faster than your third mile, like you're getting to the end. All right, so like my 5K people, 3.1 miles. Okay, so you're not going to be able to keep a consistent speed. Okay, so that's the observation we need to make here. I'm going to do another problem in a minute that kind of takes this example, and we're going to add one more element to it. We'll save that for just a minute. Okay, for now, I want to do this one. All right, this one's very similar to the one we just did. You do 120 sit-ups in 3 minutes. Your friend does 148 sit-ups in 3.5 minutes. So your friend isn't necessarily better, okay, because they did 148. They actually took more time. So you can't say your friend or you, either one is faster. You actually have to just see if the rates form a proportion. If they do, that means that they actually had the same rate. They had equivalent rates. All right, hopefully that makes sense. Go ahead and set up your proportion and test to see if these rates are equivalent. Okay, so my first one, I did 120 over 3 equals 148 over 3.5. All right, can someone explain to me how I could actually do this mental math without using my calculator? All right. So we talked a few minutes ago about when I'm multiplying a whole number by decimal value that has that half part of it, what I could do. Aiden?
You could just do 3 times 120, and that's 360, and then half of 120 is 60. So just add that, and it'll be 420.
Perfect. 420. No calculators needed. All right. Very good. Great job. All right, so that's going to be 420 for the first one. And then here's another mental math hack, okay? 3 times 148. I know that 148 could pretty easily round to what number? Are you guys paying attention? Y'all paying attention? 150. So 3 times 15 is what? 3 times 15? 45. Then add your 0. So what I'm saying is 3 times 150 is 450, okay? Now, how many shy of 150 is 148? 2. So then I would do that times 3, and I would get 6, and then subtract it to get 444. 444, okay? Yes. So, listen, when you start catching, if this is blowing your mind, that's okay. But throughout the year, we're going to do this as much as we can. I promise you, if you'll keep an open mind, this actually gets a lot easier. Okay, so Isla, do you want me to go through it one more time? Okay, so do you see how 148 was only 2 shy of 150? And I multiplied 150 3 times. So that means 3 times I was 2 shy of 150. That's 6. That's where I got the 6 from. So then I subtracted it from 444. Okay, so that's okay. Guys, if you didn't quite get it, that's okay. You are allowed to use your calculators. All right, so 420, going back to what I actually am trying to solve for, they actually don't equal. So my rates were not the same here. My rates were not the same. The answer is no. Basically, someone was going faster than the other one. All right, I think your friend is a little faster. Okay. And that's actually what we're going to solve for next, okay? So what I want to do now is I want to find, we can see now, okay? So this is the last problem, all right? We're almost done. We can see that our rates were not equivalent because 140 did not equal 440 did not equal 444, right? Okay, so now what I want you to do, take each individual rate, 120 sit-ups in 3 minutes. Find the unit rate for you and find the unit rate for your friend. Don't forget to label, okay? This is back to your lesson from yesterday. We've already determined that these rates are not proportional, okay? Which was today's lesson. Now I want to tie it into what we learned yesterday, and I want to compare these rates. All right, does anybody have a rate for me for the first one? What is it, Joel?
40 sit-ups in 1 minute.
All right, so I'm going to do S/U for sit-ups per minute. Very good. Can someone give me the rate for the second one? It might not be an even number. We could just kind of round it. What's 148 divided by 3.5?
42.
Okay, is it a decimal?
Yeah.
It's like
Okay, 42.3. Okay, sit-ups per minute here. But it's still easy to see who's faster, right? Okay, so if I were to ask you a question on your quiz, Okay, this is important because this is our application part of it. If I were to ask you, are they proportionate? Then you would set up the proportion and do your cross products. What if I were to ask you, who is faster? You use the unit rate to determine who's faster. Now I can clearly see who is faster. Who's faster, guys? Your friend is faster. The friend is faster. At 42 sit-ups per minute, you got to step up your game, right? Got to step it up. Okay. If you understand that, I think we're good. All right. That'll be it for our lesson for today.